it was interesting because the four of us were walking through the parking lot after the evening event last night, and you know, some woman calling herself Gozer asked us, choose how you want your conference to be emceed. And then she said that the choice had been made.
Josh, what did you do?
I just imagined the most innocent thing that could MC our conference.
See, it's funny because the Stay Puft Marshmallow Man doesn't speak. All right, welcome to day 2. How's everybody doing? All right. Just thing on? Yeah, okay. I can't really hear anything. It's awesome. Yeah, so Tom's going to kick us off, but before that, I do want to say, once again, we really appreciate the sponsors that are here. They help put on the event, so if you want to slide into their mentions on Twitter, they're going to love it, and their home office will love it, so do thank them. But outside of that, let's kick this off and get going. So, Tom, it's all you.
Morning. I'm not really sure how to follow up on that, so all right, morning everybody. So my name is Tom McLaughlin from Cloud Zero. I want to thank everybody for having a chance to be here. It's my first time in Madison, having a great time so far. And so what I'm going to talk about this morning is, there we go. Serverless Ops. What do we do when the server goes away? So when I first started working with Lambda, I immediately became enamored with it. It's the first technology in several years that I've actually gotten excited about. I mean, Docker is like a really cool packaging format for microservices, but whatever. Lambda, though, was just, it was fun, it was interesting, and it made me realize that it's really going to change how we build systems, and that's going to have an effect on what our job is going forward. So I started to have questions about, well, what would I do, you know, at like my desk each day if like the server goes away? You know, I had this like existential angst about what my role would be in tech, and that's what, you know, what spurred me to start exploring this topic and ultimately do this presentation. So who is this guy up here? That's me. That's one of my cats. That's Nutmeg. Again, I'm Tom McLaughlin, community engineer for Cloud Zero. We're an early stage startup out in Boston. If you've ever enabled CloudTrail and thought to yourself, well, now what, you know, how to actually make some sense out of this, talk to me afterwards. Happy to show you Reactor, which we just open sourced. I'm a former full-time infrastructure engineer. I spent most of my time working on automation systems, and today I do, you know, I spend my time between engineering, community engagement, and product and so forth. So I like including this little section because if you understand where I'm coming from, you'll probably understand better some of the conclusions that I make. I tend to like working in startups. I think they're a bit of a clown show, but ultimately I think they're really rewarding. And as a side effect of that, my problems tend to be a little bit smaller. I don't have Google, Facebook, and Netflix size problems, and so my choices, ideas may end up reflecting that. So, okay, so how did I come to ask this question? You know, what do we do when the server goes away? And so I'm going to tell you 3 quick stories. Some months ago, my previous employer, I was working on something, I was struggling with customer adoption, and I had it in my head, just like, what if people could just like click a link and these services would deploy in their environment, and I, you know, didn't have to worry about how people deployed it, got an easy-to-use host up and running, and then boom, like why not just try to land an API gateway? I refactored these web services slightly and put them out immediately. I was hooked. Okay. A few months before that, I was at a meetup, and there was this person who loudly got up and said, you know, I can't let developers have access, direct access to AWS, because if they do, they're going to spend too much money. And I remember just like on the side of the room, just thinking to myself, like, God, this guy's like a walking billing alert, okay? Like, I thought we'd really gotten past the point of, you know, being these gatekeepers to resources and moved on to being enablers. And it eventually hit me, okay? As I was, these two stories came together, and I realized, that guy is not gonna have a job down the road, okay, if serverless takes off. His devs, were gonna have CloudFormation, JSON, or serverless YAML living in their own repos, and they were gonna be making changes all the while and completely bypassing him. He was no longer gonna have any sort of control over his that AWS environment. And how many of us had a hard time with the DevOps transition in their organization? Or you had friends that had a hard time, okay? You had friends where you'd see, successive bimodal IT reorgs, and there was always those few people that kept being left in sad mode. And with that, so this actually happened to me. A few years back, I worked for a company that was at the front of the whole DevOps thing. And ops had moved into product engineering. We were just another engineering team. My job, we treated Puppet as software development, and then started noticing this other engineering team started building paths. And one day, my VP of engineering sits down with me and says, if you don't code, you're just another IT person. And I'm just like, wow. I had to learn Java, or I was not going to be there anymore. So definitely the lowest moment in my career. I didn't get up yesterday and tell it because I didn't want to spoil it for today. I still harbor a grudge with that VP of engineering and that company over the way I was treated. I'm not going to tell you it had a happy ending. It didn't. Rather than, I started trying to learn Java, it wasn't working, and rather than suffer the indignity of just being tossed aside, I said, screw it, I'm out of here. So I don't want to repeat that again, okay? And as I saw Lambda coming, I said, you know what, I want to be ahead of this curve, and I want others to get ahead of this curve too. So that's really, that's what ended up spurring on this presentation. So what is serverless? A lot of us, the term is still new to us. Not everyone has had a chance to decide whether or not they hate the term. 2007, we were arguing, saying the cloud is just somebody else's computer. 2017, we're arguing that serverless still uses servers. Yes, it does. Serverless and observability seem to be the two words our community loves to nerd rage over constantly. There are still servers involved, but not ones that I manage or I can SSH into, just like I don't manage the hardware, the underlying hardware of my EC2 instances. So, TLDR, a serverless solution is one that costs you nothing to use, or that costs you nothing to run if nobody is using it, excluding data storage. It's doing something or it's not. That EC2, that system running on EC2 instances, in the background, doesn't matter if it's idle, it's still running. You still have to maintain it, and you're still paying for it. And it's not that case with the serverless systems. Some characteristics of serverless systems: little to no infrastructure to maintain, no servers. Everything is a system. You're building something composed of multiple independent pieces that need to work together. It's event-driven. It's doing something or it's not. It's consumption instead of capacity-based pricing. So that system you built, where you built a system for 10,000 users, but you only have 10. You're still paying for the capacity for 10,000, to support 10,000 users. Yes, there is resource elasticity that only helps so much. And finally, you scale systems and the component pieces scale themselves. So I'm not responsible for scaling Lambda, SNS, SQS, S3, etc. I'm responsible for the system as a whole and its ability to scale and handle events. Some of the components, this is very AWS-centric. Lambda is usually the thing that we most commonly think of when we think of serverless, but that's simply just the functions as a service part. That replaces the EC2 for your infrastructure as a server, EC2 for your compute layer. You've probably used many of these services before. You're probably using S3, maybe some DynamoDB, SQS, SNS. Lambda just might be the current new thing to you. So now for why you're here. Where do we fit in going forward? So ops will go away about as much as it did with the adoption of public cloud. which means it's not going to, but we will be changing. So every single major change in technology seems to herald the death of ops, and it never happens. With every single change, we end up adapting, with every single change in technology, we end up adapting to it. The key is for us to identify those coming challenges ahead of time and to redefine our roles. And for us to redefine our roles, not for other people to redefine our roles for us. So, what are some of the skills we have that are definitely still going to be valuable? Okay. Systems engineering. We build, operate, debug systems. We know how things work, okay? We know AWS performance limits, AWS limits. We know performance characteristics of AWS services. We know our tooling inside and out. And finally, going on to understanding how things fail, that's as much of what we do. We're always worried about, okay, how is this going to break when it's in production? And arguably, our systems engineering skills are going to become even more important if you adopt a serverless architecture. Everything is a system. Okay? And these systems can become complicated, and not every single software developer is used to this level of complication. What we're going to how we're going to have to change, you will need to code. Okay? If you haven't been learning to code some form of language yet, you need to get on this. I don't think you're going to need to be a senior software dev caliber engineer, but you maybe should be able to pass as a junior dev or a pretty smart intern. You're going to need to know the syntax of the languages, to be able to code simple tasks and fix simple bugs using the preferred language of your organization or team. You're probably not going to need to know how to fizz bugs, but you are going to have to know how to receive an event, process it in some way, and move it on down the road. And so, how might this play out? What I see is, who here is familiar with product pods or feature teams? Okay, good, a few of you. You have a product manager, a tech lead, front-end dev, back-end dev, designer. And what I see happening in these sort of organizations is the ops team being dissolved and the ops members being redistributed into these product pods. And that ops player is going to play a variety of roles within this pod. So they're going to be a sort of utility player. So as your devs are busy building features and shipping, ops is going to be there continuously involved in ensuring the reliability and performance of that system. But we're going to do it as a team member inside these smaller teams. I think that team membership is going to be one of the most important parts of this. If we're not directly involved in this, we're going to be bypassed, we're going to become invisible, and we're going to be seen as less valuable in these organizations. So, here's some of the ways I see the ops role being defined on these teams. I'm sure these aren't the only roles, only things that we will play in this role, but this is just the start. So, define the ops role. Developing system standards and best practices, knowing our build, deploy, and management tooling, and ensuring the reliability of systems, code review, that might be new for several of us, performance tuning and scaling systems, and evaluating costs and systems. Again, a lot of these are things we were already doing, it's just that the job is going to be slightly different. So, diving into each one of these, developing system standards and practices. What AWS resource patterns do you use and when do you use them? Do you have strong opinions on the proper patterns to build reliable systems? Good. That's going to be really useful for your organization. Next few slides are actually a presentation that I think could actually end up being on its own. It's actually the next one I'm building. This is message passing. Okay, this is the heart of all your AWS serverless systems, getting an event from A to B. And there's a lot of different ways to accomplish this, with many different pros and cons. So I'm going to start with just simply using SNS here. It's one of the most common ways that you're going to see systems being connected. It's great for extensibility. Need to add a new feature? Great, just add a new topic subscriber and there you go. SNS guarantees delivery, but you also need to make sure that the topic subscriber is able to properly handle that message, and you should probably end up setting up some sort of dead letter queuing system for SNS to handle failure. Some questions for you, for you to ask if you decide to go this route in the system that you're building. Okay, how many messages are you going to pass? Every single one of those messages is going to result in a Lambda invocation. Let's say you're breaking up an AWS billing report by line item. You're sending each one as its own message. Are you going to end up hitting like an AWS Lambda execution limit for multiple simultaneous Lambdas? Also, how much is that actually going to cost you too? Is it better for you to, send every single thing every single line item as one message and one invocation, or is it better for you to batch them? Going on to SQS, okay? It's durable. Lambda, a Lambda failed, a failed Lambda, okay, fine. The message stays in the queue and it's retained until another Lambda invocation picks up and tries to process it. Unfortunately, unlike SNS, SQS is not an event source, which means you have to then start deciding about, okay, well, how am I going to trigger this? Am I going to trigger my consumers based on a timer? Or am I going to trigger my consumer based on the state of my SQS queue? More questions. What does my workload actually look like? Should I be using, just one long-running recursive Lambda that keeps calling itself, or should I fan out to multiple consumers? You're going to need to know what your workload looks like in order to figure out what is the best thing for us to actually ship. Another common pattern, SNS to SQS. This is the one that I tend to use the most. Combines the pros of SNS and SQS with all the exact cons of SNS and SQS, and you pay more money. I don't pay the bill, so. This is a Lambda fan out. This is the one that makes me cringe every single time I see it. It's blazingly fast for one Lambda to invoke another Lambda. However, your calling Lambda needs to be good at handling errors. Okay? My own preference is to rely on the design of the system to gracefully handle and catch errors instead of relying on a developer to make sure they did all the correct try-catch stuff. And I'll just point out, S3, Dynamo DB streams, Kinesis, and many more or just other ways that you can achieve all this. Like, again, you can just keep up the developing patterns. So, knowing the build, deploy, and management tooling, you want to be the resource for actually how to get services out the door, and you want to be able to expend your tools. If you spend a lot of time with CloudFormation right now, awesome. Because you want to know something? Developers really don't like CloudFormation. Okay, when there's a CloudFormation question and how to get a resource out the door at Cloud Zero, it usually ends up coming to me. If you aren't that approachable person for this, what you're going to start finding is developers are going to be creating S3 buckets with DynamoDB tables with Bodo instead of in CloudFormation, and you're going to find all these untracked resource dependencies that you never even knew existed. Being able to extend the tooling, if you're writing custom, Puppet Facts or Knife plugins for Chef, same thing. You just might be writing some JavaScript at this point. So for this, this example, I want to add alerts to my SQS queues. Awesome. Okay. So I'm going to start adding. CloudWatch alerts, and then I want to move on to finding to either writing or finding a plugin that'll do this for me. And now I've broken it down so anyone can add an SQS alert to their queue. And right here, adding 4 alerts is now way easier than it was for us to just add 1 alert to our system. So going on to like us handling the reliability of our systems, what do we monitor, what do we measure, how do we make sure our systems run fine? Sooner or later, someone is probably going to try and ship this into production, okay? More likely to look something pretty simple like this. Here's a really basic system. You have S3, and an event triggers Lambda, takes that, sends SNS through SNS to SQS, and then on a timer, a consumer is going to pick those messages up and insert it into DynamoDB. And what you should be seeing in your head once you're presented with this is something more like this. Okay? What happens if that S3 object becomes too big? Well, I'm probably going to want a CloudWatch alert or a CloudWatch alarm for average invocation time. And if I start seeing that it's trending closer to 5 minutes, I'm going to want to refactor that Lambda so it's a recursive call to itself, so that it'll keep processing. And since it's a recursive, Lambda, I probably also want to check, have an alert on the number of invocations that are occurring. Because when you put a Lambda into an infinite loop, it becomes very expensive. I've done this before. Going here over to SQS, I said consumers, you can't use SQS as a trigger to a Lambda. So okay, right now I've just got a time trigger. But here we go. We've got CloudWatch alerts. We say the first one, low mark, that's actually just going to trigger an additional consumer just to try and clear the queue. And then if we get even higher, that's where we're actually going to wake somebody up. Code review, okay? I keep saying we're going to have to be able to, we're going to have to get more involved within this. Are we building systems that are in a manner that makes them, maintainable? So we want to make sure that our developers are adhering to best practices. And some of these are simple things like, okay, instantiate objects outside of your handler so you can make use of what's called container reuse on AWS. When first time you invoke a Lambda, a container is spun up, and that container remains for a period of time until it's eventually killed. Lambdas are functions, okay? And the best sort of functions just do one thing. One is a fungible definition. But here we go. We're just going to take a message and we're going to archive it to S3. That's the sole purpose of this particular Lambda. And finally, we're going to pass, the parameters about our system, like our S3 bucket. We're going to pass those in as environmental variables. We don't want our developers hard coding these sort of things into our systems. Again, this is when you start finding untracked resource dependencies, and you don't know how your system works after a while. So it's very easy to build a monolith with serverless. This is not, a serverless system. This is a SaaS platform. Okay. I mean, you've got your customer over here, and you've got your PM over here, and they're all somehow contained and users of this one repo. So someone's going to need to be responsible for breaking up these systems into logical pieces and putting them all back together. I don't have actually a good answer for this. This is something that is still up for debate within the serverless community. How do you actually logically break down your systems? My own personal preference, again, you can see why I like SNS so much. It just creates a natural point for you to say, yeah, that, and that are all just actually different and probably should be self-contained. So performance tuning and scaling our systems, what we built for 1,000 people isn't going to necessarily work for 100,000 people. And so somebody's going to be responsible for refactoring that system, and it's probably going to be you. And so in this case, we know what I built before, that mousetrap thing. Sure, okay, we got to a point where this SNS to SQS no longer was cutting it. So it would be my responsibility to then refactor it to use, say, Kinesis streams or something like that. AWS X-Ray lets you profile the performance of your systems and applications. It's going to show you where your systems are spending most of their time. And I expect, as the ops person, this is going to be you're going to be the first line of defense when somebody says the system is slow. Okay, you're going to end up spending a lot of time in here going, okay, where are we actually spending time? Where are the parts of the system that we need to investigate? Cost of systems, okay? There are two types of scaling limits in AWS. There are those directly imposed by AWS, and there are those that are imposed by your wallet. You're going to have to keep costs in check as you scale. Even if I, sit there and build really, AWS, SNS to SQS and spend more money. So I coined a term application dollar monitoring for this. Your price is going to become a system metric that you're actually going to have to track. So this is the average cost of invocation for some sort of system. And every single change you make to that system is going to have some sort of cost change, positive or negative. And the cost change looks small now, but when you start scaling that to millions and millions of invocations, that ends up becoming some real money. So, for instance, right over here, okay? Somewhere in there was a change to our system, and we've now bumped up the average cost of invocation. If you were to say overlay that with your feature deploys, now you're going to want to say, okay, what was the feature that we deployed here? And is it really worth the, the change in price that we're actually getting, for this system? And so finally, okay, we have adapted before, and we will adapt again. I think serverless is absolutely exciting. I think we have a lot of value, and I think we have perhaps even increased value in a certain serverless architecture, but we need to be able to redefine our jobs instead of having our jobs redefined for us. And so what I hope people have gotten out of this morning is just some direction of what they want to learn with serverless and investigate where to go. If you're interested, shoot me, just find me after this. Happy to talk with you anytime. And finally, my feedback form. If you have any feedback for me as a speaker, for my talk and so forth, just go to straycat/feedback, strayc.et/feedback, and let me know what you thought. Thank you.